Hello, my name is Lance. I'm also known as Nemus. If you are familiar with who I am, I do stuff in Salt Lake City. If you want a copy of the updated presentations, just go to my website, obscuritysystems.com. There's a link there to the presentations. You can get a updated version than the one that was on the torrent or download from the website. Just a little quick piece about me. I'm Vice President of Software Engineering for a banking software company. GWAP is part of my alphabet soup. I help maintain and manage the local DEF CON group in Salt Lake City. I've done a couple of DEF CON presentations, and then I do local presentations. I'm also part of the HACKWEST board. Our CFP is open. I will be running the villages at HACKWEST this year, so if you have a village idea or a presentation idea that you probably didn't get ready for SAINTCON and you still want to give it this year, go ahead and go to cfphackwest.org and submit a CFP for us. All right, so let's get started on the presentation. I put a little bit of prereqs in my presentation for beginners because it might be a little bit confusing for some people, especially if you're a newbie. I try to make things as easy as possible. If there's something weird in my presentation or something technically wrong, because things do change, just feel free to reach out on Twitter or email or IRC. Another disclaimer. So today I'm going to be talking about some weird stuff. One thing we're going to be talking about is counter hacking. I'm not going to tell you how to, but it doesn't take much to jump from what I'm saying to something very illegal. Again, I'm not responsible for what you do. If you have questions or anything, you can reach out and talk to me, but I am not a lawyer. I don't claim to be a lawyer. I don't play a lawyer on TV. I am not your lawyer. So I am not responsible for anything dumb that you might do. So I wrote this presentation because I kind of hit this point where we had our IDS set up, we have our WAF set up, and we're just looking for alerts and we're looking through false positives, but there's something kind of missing from that, right? I come from a real-time strategy kind of background. That was something I was really into when I was younger. I really liked StarCraft, I really liked Warcraft, and the thing that you learn from that is what? The best defense is a good offense, right? If you want to have a good offense, you're much better attacking the enemy, going after the enemy, and giving them something to deal with, something to manage, than you are building defenses. So one thing that I found difficult is you're not really allowed to do that with information security. You're not allowed to really hack back. You're not allowed to attack back. You're not allowed to fight back very effectively without breaking the law. Because at that point, you're fighting in the mud with the pig, and you're going after, you're stooping down their level, and then you're going into a legal realm. Where if you do some counter hacking, doing some stuff that you shouldn't be doing, you're going to put yourself and your company at liability. So one thing that comes to security is my definition of security is that there really is nothing really is secure, right? If you think about security, you can't really make something secure. No one's ever safe. You're never safe, nothing's secure, nothing is ever bolted down. There's always something terrible that can happen. So my definition of security is something that when we make something more difficult or harder to obtain than it's worth, then you've made it relatively secure, right? If it costs more time and resources, more effort for me to get access to the system, for me to attack the system, for me to gain the resources of the system, then more likely the attacker is going to go on and move on to something else. Another thing too, we've always talked about obscurity. Security isn't obscurity, but I think it adds a little bit of value. Obscurity does add a little bit of value to security because it buys us time. So one thing that comes to mind is I used to think that for SSH, if you changed your port number from 22 to, let's say, a different port number, they weren't you weren't really adding value. But one of the main values you get out of that is it reduces the amount of attacks you're getting in your system. You're reducing the amount of logs you have to filter through. You're going off the norm, and you're taking your system outside of what's normal and putting it in a place where someone has to actually think about what they're doing to attack it. So obscurity isn't security like salt isn't a meal, right? It's just something we add a little bit of to add some flavor, to make things a little bit more difficult than normal, and we make it so that we're not part of the normal flow of what attackers expect our applications to be. So one of the things that kind of irritates me about being a defensive guy is I feel like from a real-time strategy perspective, we are turtling and teching. What do? We just throw as much technology as we can at the problem. We set up more devices, more things, more alerting, more technology, and then we turtle in and we just say, oh, well, they're attacking us. Let's sit there and wait for them to come to us. Let's wait for someone to attack us. And that's kind of the strategy that a lot of information security professionals have taken over the years. It's always kind of something that bothered me. So I've talked a little bit about counter-hacking, but counter-hacking and counterintelligence is kind of a way where we try and do something to disrupt the attacker or try to figure out who they are, right? If I can figure out who they are or where they're coming from and what they're trying to do, maybe I might have a better insight of what their goals are and what resources they're trying to come after. So I always like this XKCD. You know, I started doing this after I read this. It just blurted out, you know, I know you're listening. It's kind of a counterintelligent mind game, right? You don't know if someone's listening, but if someone is listening now, they're really freaked out, right? So back to the counter-hacking debate. I am not condoning counter-hacking. I'm not saying this is something you should do. I'm not saying that it's something you could do, but I'm not saying it's something you should do. It's not legal. Again, I'm not a lawyer. Doing some of this stuff, like going beyond what I talk about here, could get you into serious trouble because it doesn't take much to go from, oh, let's gather some resources to let's run, try and trick the attacker to exploiting, to downloading something or getting an exploit on their system. And again, I've talked to a couple of lawyers about the subject, and basically what comes back from what I've heard from them is that when you start fighting back, you start losing the legal higher ground, and you start losing the right to take legal action against the entity that is attacking your system. So again, this is the how, not the why. Think about what you're doing before you put on the zebra suit, right? There's lions out there where if you're trying to do counter-hacking, there are people out there that are going to be better at this for you. They're going to see some of these things coming, and you might be poking the bear a little bit. So this is one of my favorite videos. It's on the internet. How many people have seen this? Cool, one person. So he's going to be bored. Oh. I want to play this video. Nope, that's not what I want. So this is the best analogy I have ever come across of what it's like to have a server on the internet. Right? Pretend your house is public-facing server, and these clowns are just random people wandering around with a knife trying to get into your house. It's kind of scary, right? This is the best analogy I can have, because if you start looking at your traffic, you can kind of see that all these people are just randomly trying to break into your system. This is probably fake, but it's still kind of scary, right? Supposedly this is, 2 a.m. somewhere in Texas. This guy dressed up in a clown suit, walking around with a knife, trying to open windows, trying to open doors. And then here's the other scary part, is this person, as you're going to find out, didn't lock their gate, right? So now he's in kind of their backyard, looking into the window, walking around with a knife, trying to break into somebody's house. So the question here is, did this guy in this clown suit do anything really illegal? Probably not, because he didn't do any breaking of entering. The back door wasn't locked, so there was no probable reason to keep him out. There was no sign to keep him out. Depending on where you live and what state you're in, what he's doing is probably not illegal, but the knife kind of gives the intent, especially, that he has some menacing, that he's trying to do something maybe to threaten someone. If he didn't have the knife, it wouldn't be very illegal for him to walk around. It might be, past curfew or he's on private property, but there's not a whole lot you could do about this, right? That's kind of the same thing with attackers on the internet, is they're always constantly trying to get into your systems. They're always trying to attack your systems, but there's not a whole lot you can do to kind of fight back and against that. I'll just kill that real quick. So, one of the things that I started doing is I started playing around with honeypots. And this is kind of a cool little thing I found out, is the first honeypot or first honey trap was actually mentioned in the Cinderella story. The princess, when she was running away, or Cinderella, when she was running away, the prince ordered the guards to pour honey on the stairs. And that's actually how her shoe got stuck, because he wanted her to stay. And apparently her shoe wasn't worth staying, so she left. But I thought that was just kind of cool. Anyway, so who here is familiar with honeypots? Awesome. Okay. How many people have set up a honeypot server? Nice. So I won't spend too much time on this. So we have detection honeypots. We have research honeypots. Basically, we use our detection honeypot to see if we have someone attacking on our network, or if we have something on our network that we don't expect to have, right? Because we set up a detection honeypot or honey network or honey something, so that we tell our staff, do not touch this. And if anybody plays with this, anything happens on these systems, we know it's a malicious actor, or we know it's a malicious threat or malware, or something weird's going on. And this is a complement to our IDS system, because we can look at the traffic that's hitting our honeypot, and we can look at the traffic in our IDS and compare them and say, looks like the same traffic that's hitting this is also going here, so it looks like we might actually have a threat, right? This gives us way better detection than our IDS, because our IDS gives us a lot of false positives, right? It's a lot to look through, it's a lot to go through, it's lots of fine-tuning, and there's also false negatives, right? False positives and false negatives are the bane of security. Then we also have research honeypots. These ones are a little bit more dangerous, where we set them up with known vulnerabilities, set them up somewhere hopefully isolated, and then have someone come in and try and attack it, and then we got to look in to see how that process happened and what their goals were and what they tried to accomplish. So we talked about this, the Honeypot Pros. This is a complement to your IDS system. This isn't a replacement of your IDS system. So this is something that I recommend doing after you have an IDS in place, you have it under control, and you have it managed. Another thing is honeypots are very dangerous if not monitored, right? Because they're kind of like thinking about live weapons. If the honeypot is unmanaged, unmonitored, and you just set it and forget it, someone's going to compromise it, and then they're going to figure out maybe it's a honeypot, and then they're going to try and use it to leverage to get into other systems. So it's something you have to make sure you're monitoring and you're protecting, and that you're prepared to burn or wipe or destroy it if it gets out of hand. So now I'm going to get more, now that we've gone through more of the kind of theory or explanations, I'm going to talk a little bit more about technical solutions using open source software. These are all simple, easy to introduce solutions that are based using technology that's free and available. Again, the thing to remember about this stuff is you do not set it and forget it. This is not a wrong co solution. A lot of people want information security to be, set it, forget it, and then just look at the logs every once in a while. A lot of this stuff does require a lot of care and maintenance and monitoring. For this, I've got in my environment Elasticsearch, Logstash, ModSecurity, Nginx, and Apache. This is all I've used to set up my environment. And this is a little bit of the diagram of I've been setting up and toying with in my test environment. I haven't actually gone live with this. But basically, I've got a Honey server. It's in its own DMZ. It's isolated from the production environment. It's a copy of our production environment. of the one that I'm protecting. And then we have our counterintelligence server. The counterintelligence server is actually a independent server that I have to use as a resource to gather information about possible attackers. And this server is on a cloud. It's completely separated from my network, and my goal is to keep it so that it's not part of what I have here in my setup. So one of the things I'm doing to redirect web requests to our Honey server when I've determined that they're malicious is I set up a reverse proxy setup. I use the reverse proxy to do routing of traffic between legitimate traffic and illegitimate traffic or attacker traffic. So here I can use the reverse proxy to switch between the back-end web servers. Everyone familiar with a reverse web proxy? Yeah, most people. I'm using a combination of Apache and Nginx. I ran into two problems with this. First, the versions of Apache I was working with were older than 2.4, and the if statement functionality for doing reversing or looking at HTTP parameters was not available as much as I wanted to, and it wasn't as featureful as I wanted to. But Nginx integration of ModSecurity isn't where I'd want it. Where if ModSecurity, you have to compile ModSecurity with compiling Nginx, and that was more work they wanted to do. So I'm actually using two reverse proxies, one for ModSecurity and one for routing traffic. And so on this Nginx reverse proxy, basically what I'm doing is when I've determined a actor as being malicious, I can set inside that HTTP request a header saying, hey, redirect this to our honeypot. And based on the HTTP header that comes in the request, it'll redirect it to the production servers or into the honeypot server. Another cool tool I've just started playing with is Kong and Openresty. Kong and Openresty have the option of building in HTTP request modules with Lua. Makes this part a little bit easier and gives you a little more dynamic control of how you're redirecting web requests and how you can kind of control the traffic a little bit. I haven't had enough time to really dig deep into there, but the nice thing is it's very programmable and very changeable and modular. So it's a cool thing to look at. The next thing too is I set up fail to ban to kind of help me with blocking, protecting my network, and just implementing whatever active defenses I was going to put in place on my web application servers. So here's just basically my setup. I have a personal hatred for Firewall D. I'm sure it's fine. I just grew up on Iptables, and so switching is not something I wanted to do. So now we're going to talk about Honey. And when I talk about Honey, I'm going to talk about setting Honey traps, or little alerting flags or things that we can do on our operating system and on our network to identify possible threat actors. So these are all my definitions. I haven't been able to find an authoritative source to kind of really go through and define these, but I see there's Honey systems, Honey tokens, Honey tables and databases, Honey domains, URLs, Honey files, and Honey ports. So these are all kinds of things you can set up to do detection and alerts on your systems and to see if someone's interacting with your file systems or operating system or something that you're trying to protect against or identify as a possible threat. So another thing too is a lot of the stuff I'm going to do, if you guys have regular pen tests, this is a bad idea for your pen tester because this is going to make their life hell. And if you're spending a lot of money on your pen test, you probably don't want them testing your active defense solution. I mean, if you're paying them like, hey, we developed this new active defense solution, we want to test it, that's different. But if you're going through a normal pen test, you want to find vulnerabilities, the whole goal of a lot of this stuff is to waste people's time, right? Because time is money, time is a resource, and for attackers, if I can make it difficult to attack my system, they have to spend more time slowing down their connections, making it frustrating for them, there's a good possibility they'll move on. So one of these two is setting up Honey domains. And so what pen testers will usually do is they'll go through and try and look for systems like test systems or unused computers on your network or domains that they could potentially launch attacks against. So one thing you can do is you can set up honey domains. You can set up a lot of these so that there's a lot of things on your network that could potentially be scanned or identified or possible points of attack. And you could have them redirect to different servers or other things, and there's a list of using Fierce. And Fierce is a tool that basically just goes through and brute forces DNS names and tries to look for servers that will respond to those DNS names. So here's a list of possible domain names that you could set up honey domains on. And so if someone starts interacting with these, then you know that someone might be attempting to attack your network or trying to do something malicious, because A, you haven't published these names, and B, they're in the Fierce domain set. Someone's running Fierce against your network or against your domain, so maybe there's something malicious going on. So this is an example of a honeypot using Iptables and fail to ban. So in this example, what we're doing is we're setting up honeypots, and then these honeypots are basically, if someone interacts with them, an IP address interacts with them, or something happens, in this example, we're banning them. This is also bad, right? What's bad about this? What's bad about this is now I have a way to DDoS your system. Because if I go to your most popular customer, like maybe you're hosting a site for a university, and I go on that university's network, and I just ban all of those IP addresses on that network, then they won't be able to access the server. So one thing that you could do is you can set up Iptables rules to just rate limit them, right? So if someone just scanned your system, you can then put an Iptables rule in there that maybe this IP address, let's just slow it down, right? Let's maybe slow it down for 20, 30, 40 minutes or whatever, put a time limit or something. And that way, when someone's scanning your network and they've run a scan, now when they run more scans, it's going to take even longer, and they're going to get frustrated and maybe move on to something else. Another thing too that I recommend doing is a lot of hacker tools, a lot of pen tester tools have user agent strings set for them. And if you just block user agent strings, you will prevent a lot of script kiddies, a lot of malicious actors, a lot of people that are just opening up tools and firing them and trying to figure out what's going on. So you just set up a user agent string blocking in the HTTP request. And you just say, hey, if you're using a non-standard user agent string, then just drop the request, right? Makes it difficult for someone to scan. Again, too, this is something you should tell your pen tester or someone who's doing an audit on your network, because if they're running Burp Suite or they're running something that has a user agent string that's going to modify it, and they might not be familiar with this, they aren't going to say, oh, we didn't find anything. Well, it's because I blocked your user agent string. Again, so this is just the Apache config. We look at the agent string of the denied list. We can set up fail to ban, so maybe we can block them for a certain period of time. We can protect against brute force login. So this is another thing. This is just using the ModSecurity rules. And so what this does is if we have a login on one of our systems, we can configure it so that if they have a lot of failed login attempts, we can just block them or ban them or do something, do something with it, right? And this is the great thing about this is I don't have to modify the code of the system, right? The developer wrote the system. It does whatever it's going to do. But if I find too many failed requests, I'm going to block them or prevent them from getting access or do something to change the outcome. Too. So another thing we can do is if we notice someone trying to brute force a login attempt, we can redirect them using mod rewrite and give them 500 errors, right? Once someone's trying to brute force a login or trying to attempt something, we can try and set up a mod rewrite trap or set up something so that when they go to the website and they're running their intruder attack from Burp Suite or whatever automation tool, we start spitting out weird random results. And then what are they going to do? They're going to have to go back and say, why did this happen? And we're going to send them in a loop, right? We're going to send them to make them have to think about what's going on, set up bad requests, bad responses, and things like this. So basically, this is pretty simple, right? This is just a simple PHP script, and all it does is return random HTTP response codes. So we return 404, 403, 501. And we can combine this with mod security rules or mod rewrite rules and fail to ban or whatever we want. and make it so that it's frustrating for someone to attack or attempt to brute force or log in, or if they're mapping or they're going places they're not supposed to be, we start sending them weird random responses. And the thing about 500 errors is usually that's an indication of an exploit or a possible attempt, break-in attempt, a place that you could try and break in. So if you send them just a little bit of what they want, we can entice them to go down an error or down a rabbit hole that we want them to, and they'll make more noise and make themselves known. So another thing too, what kind of started me on this path is I started looking at my logs, right? How many people look at your Apache logs? Everybody raise your hand. You're going to do this. It's fun. It is, trust me. It's fun to watch these bots come across and say, hey, every bot in the world loves PHPMyAdmin. Every bot. That's the thing they want. My first rule in my development environments is you will not install PHPMyAdmin, right? I tell people do not use that. Why? Because the chances of you making a mistake are really high, and everyone is expecting you to make a mistake. And every bot I've ever come across, the first thing they check for is PHPMyAdmin. So one of the things that you can do with that is, well, if they want PHPMyAdmin, stop. Is that we can give it to them, right? We can set up a fake site with what they're expecting and just let them hit this fake site and try their attack against the PHPMyAdmin clone that's really connected to nothing. Is just a huge waste of time. Again, too, with ModSecurity, with these rewrite rules, you can define which IP addresses are allowed to log in or access which URIs. So we can say this IP address is allowed to access the WordPress login page, and then other people get redirected somewhere. The cool thing about this, too, is you can set up rules and things like this based on failed login attempts, and you can get really complex on these things. This is just a small snippet to get started and kind of give you an idea of the things you can do. So another thing that we do on our DC1 website is we have a robots.txt, and then we have these sites that are all disallowed. And basically what robots.txt is a list of sites that we're telling bots, do not go here, right? And if if someone goes to a place we told them not to go, then obviously someone's trying to do something malicious or something dumb. So we have a bunch of places where we tell people not to go, and then we can use that data to say, hey, this is a potential threat actor. So going back to the PHPMyAdmin, we can set up a clone of a site just using HTTP track, and we can set up a fake PHPMyAdmin site for bots to attack and send requests for, send exploits for, and kind of detect what's going on there. Another thing that we haven't talked about yet is the honey token. So this is an example of setting up a very simple honey token. And so a honey token is basically just a piece of data in your database that shouldn't be used, that you know about. So if you have credit card numbers, you have social security numbers, or whatever, you set up one of these honey tokens, and you put a bunch of them in your database, and you tell admins and you tell people, do not use this record, do not use this value. If you do, the security team is going to come and talk to you. And what this does is anytime someone in the MySQL database accesses this data, it's going to get put in the query logs, and we can see this token, and then we can send an alert. So we know that no one is supposed to use this token, and if someone does pull it, then maybe we've had a breach and someone's pulled our SQL database and we need to go do an investigation. So we've kind of set a trap, and here it's really simple script, where basically all you have to do is set up query logging on MySQL, and then look for your token, and then it'll send you an alert if that token ever fires. And then this is a little bit more complex setup. I used name pipes to write my MySQL query log just because I wanted the operation to not be against the disk. I wanted it to be directly against memory. You can set up a RAM disk or anything and log rotate with the files and other things like that. There's more details here. Excuse me. So the next type of honey token or honey table, honey is the honey table. Honey table is just like the Honey token, except this is a MySQL database table, or, sorry, my voice is going. This is a table that we know that shouldn't be used, and then we do the same thing we did with the Honey token, and if anybody tries to access this table, we know that we might have a malicious actor on our system. Again, this is a ModSecurity Honey token detection. So you can look in the HTTP request. So if you see your Honey tokens coming out of your HTTP request, then you can set up alerts for that on your ModSecurity device and send it out to your system and your security team. This is another one of my favorites, is Honey files. So a malicious actor on your operating system, they're going to be looking at the administrators, they're going to be looking at the history, and they're going to say, you know, as an attacker, systems.password.txt, that seems interesting, right? That seems like a place there might be passwords or something in there that I might be able to get access to. And so using the iNotify commands, how many people have used iNotify before? Cool. iNotify is one of my favorite things because it hooks into Linux kernel and it gives you actions on file operations. So if someone touches this file, with this iNotify process in place, it'll send you an alert, and you can say, hey, this file got read. So you know someone was on that system that wasn't supposed to be. So another thing you can do, and so this is kind of gets more into the counter hacking a little bit, is the Honey docs. So we can set up a document maybe in a shared folder or shared file share that has Honey data in it. Honey admin, credentials, Honey users, Honey passwords, and then if someone tries to log into any of our systems using those values, when we set up our logging, then we know that they downloaded the file, and B, they're trying to access things that they shouldn't. There used to be this awesome project called the Decloaking Engine. The Decloaking Engine was done, I think, by H.D. Moore. The project's currently dead. Basically, it was a tool that you could set up a website or set up things that would help you detect if someone was behind a Tor node and try and determine where they were behind that Tor node and where they're coming from. It's kind of sad that I don't know if the Tor just fixed those vulnerabilities or what, but there's no tools out there that I could find that would do that. So now I'm going to talk a little bit about counterintelligence gathering. I did have a little bit more detailed stuff about this, but I tried submitting this talk to other conferences, and the feedback that I got back from everyone was that they'll shoot your eye out, kid, right? Like, we don't want to teach people about counter hacking. We don't want to teach people to do malicious things because they're going to hurt themselves. So I've kind of changed it a little bit about counterintelligence gathering. So how many people have used Beef? Good. Good. We have a good lot of experience in this room. So it doesn't take much logic to think about, at this point, if I wanted to fight back, if they're willing to download files from my web server, they're willing to access my web server, I might be able to convince them to run Java from my server, right? What happens after that, right? You could, maybe get them to run an exploit. You could maybe get them to, run malicious code on their system because they're more focused on attacking your system and getting access to your admin portal than they are really thinking about their defensive. But at that point, you've kind of broken the law. But some things you can do if you wanted to determine maybe who this person was, and it's a little bit benign, is to set up a beef hook. So we set up a beef hook in our false admin portal or our false web application sites that we have as Honey tokens or Honey sites or Honey URLs. And then if they actually go to that with a browser and try and interact with it, maybe we can get a beef hook on them, and we can use that beef hook to gather intelligence about that person. If you're not familiar with what beef can do, we can do network discovery, information gathering, there's social engineering things, geolocation, you can get a little bit of persistence with it. Beyond that, we kind of get into the realm of legal gray morality. So I'm not going to talk a little bit further about that just because I don't want to poke the bear. But I mean, this is just some of the information from my browser that I got from doing a beef hook. You get IP addresses. You can see if they're running Flash. You can maybe determine if they're using Firefox or where they are, region-wise based by the language that they're using on their browser, things like that. Another thing that I thought about going further on this is a lot of this stuff requires manual setup, like with the file iNotify stuff. So if an attacker was aware of honey tokens or aware of these problems, they could try and disable them. The only way you could kind of get invisible to the people knowing that you're monitoring your system is if you get into the kernel level and kind of do some of your own rootkitting of your own systems, but that gets a little bit more complex and it's kind of beyond the scope of this presentation. But what I've seen from honeypot systems that are built out there is that what they'll do is in the kernel, they'll send out logs, and because they don't want to identify where the logging server is they'll send out their log encrypted in a UDP packet that will go to an IP address that doesn't exist. And what they'll do is they'll set up their logging on their span port, and the span port will just look for that fake IP address and pull the logs off of that. So the attacker doesn't know where the logging system is. They only see these packets leaving and going out these random IP addresses, and they can't really do a lot about it other than shut down the system or block the traffic going out. A lot of this stuff comes from Paul.com, from his offensive countermeasure stuff. That was another inspiration for this talk. I wanted to see if a lot of his stuff was still relevant. Some of it is. A lot of the other stuff has kind of gone to the wayside, but he wrote a really good talk about a lot of this counter-hacking stuff and some of the more malicious ways you can counter-hack and set up sites and traps for other people or hackers that are attacking your systems. And so these are my references, and that is it. Thank you. Question? So that's what the counterintelligence server is for, is I run beef on that server. So repeat it so everyone can hear it. The question was, do you run beef all the time so that you know if you get alerts and stuff? Yeah, you can set up, I have beef set up on the counterintelligence server, which is completely separate and disconnected from the rest of the network, so that when they go to that site, the beef hook comes back to me on my VPS, which I could, if I made a mistake, I could burn it and destroy it. And yeah, I just set it up and set up an alerting in it, logging in it, and then if someone interacts with it, and if they get a beef hook, you can have some automation built in with it too, where if they get hooked, it'll go and gather some information, and it can send you an alert and say, hey, maybe someone's trying to attack your system. This stuff doesn't work very well if you have a web-faced or public-facing site. But if you wanted to detect internal threats, it's really great. So if someone on your network, internal network, is attacking an internal web application that they're not supposed to have access to, and then they get a beef hook, then you know maybe someone in your department's trying to log into an admin portal they're not supposed to, like why is accounting trying to get in there, or maybe their system's infected, or maybe there's a pen tester in your network that's trying to leverage your help desk or your reception desk to try and gain further access to other systems. So I found a lot of benefit with it on internal sites. External sites, you're going to see a lot of just people trying bots and other things. So that might not work as well. Did that answer the question? Okay, good. Any other questions? Cool. So we got a little bit of time. Does anyone have any questions about like the hackerspace or anything else they'd like to talk about? HACKWEST is in March. I want to say March 20th. I guess we could go look. March 21st, 23rd, so it's a day off. We'd love to see you guys there. We're looking for CFPs. We're going to have villages and stuff. A lot of people were concerned with HACKWEST and the separation from B-sides. If you guys have questions about that, you can come talk to me. I'm on the board. One of the main reasons why we separated from B-sides and started HACKWEST is just so we could do our own thing and we could have our own independence. The B-sides framework is really great. It's awesome. I have nothing negative to say about the B-sides framework. It's a great framework and it's a great place to get started. But the whole idea between HACKWEST is just kind of give us the freedom to blaze our own path and do our own thing. So that was our goal with it. There'll still be B-sides this year. B-sides Salt Lake will be at the Salt Lake Community College. I guess we could go look at that too. March. It is a week before. And Bryce is here. He can come. That guy. Yep, so that's March 16th, the week before. We have the call for papers is up. I'm helping Bryce with that. I'll be on volunteers. With HACKWEST, I'm doing villages. So if you want to volunteer for B-sides, let me know, let Bryce know. We'd love to have help. We'll love to have people out here. You guys make the community, so appreciate it. All right. Cool, thank you.